Okay, so something we were doing yesterday was we were looking at perfect square trinomials. So we looked at these two-term quadratics that you had your A and your B, but then we were looking what is that C that would add on there so that it would factor into those two of the same factors. So both of your factors for this quadratic would be the exact same thing. So we had to figure out what could we add to the end of that quadratic to make it have the same factors. So what were we adding during our quadratic for our complete the square yesterday? So we always added b over 2 squared. And the b just depended on whatever that second form was. Whatever that number in front of your just single x, that was always your b. So in this case, we have our 12. So we'll be adding, it'll be x squared plus 12x plus... That's a b. Here, I'll make it a capital B. I'm sorry, my b's look like 6s. The one issue I have. I have lots of issues. I'm not with that. So 12 over 2 squared, we can simplify that. 12 divided by 2 is 6. And then 6 squared is 36. So we had x squared plus 12x plus 36. That would be the perfect square trinomial. So once again, we're using that b over 2 squared during our complete the square formula. That's going to be one of our steps we use. So this is just a review over one of the steps we're going to do. We'll go over like a whole problem in just a moment. Don't worry. We have a trick with this for factoring. Because of the perfect square trinomial, it always jumps to a specific factor. So rather than having to think, okay, what two numbers multiply to get 36 and add to get 12, we can jump directly to the answer. Because we knew that factor was, because we knew it was a perfect square trinomial, we knew that answer always had to be a specific thing. So it was always going to be x plus your b over 2. That's always what it factored into. Assuming you added b over 2 squared to both sides, or assuming you added b over 2 squared to the end, it should always give you this as its factor. So it was like a shortcut. We could always jump right to this. So in this case, if b is 12, our factored form of this perfect square trinomial would be x plus 6 squared. And that was one of our little shortcuts we used during this complete the square method to sort of shorten it. So we don't want to have to factor in the middle to complete the square. It just would take a long time. Are we okay with this so far? Remembering this from yesterday? So, the main goal once again for today is just to walk through those steps for complete the square, just getting familiar with those steps. For completing the square, there were 6 steps that we listed yesterday. I have them listed on the side so we can review them again as we walk through the problem. So the first thing is we had to move c, then we added b over 2 squared, then we factored the left side, then we simplified the right side, took the square root, and then we split it into 2 problems. So we're going to walk through these steps on these problems, see a couple examples, and practice it a little bit, and then we're going to see something that's just a little bit different and see there's a problem that's a little bit tougher. Questions to start with at the moment? All right. You okay about it?
Mm-hmm.
All right. So, you okay, Ashton? Yeah, I'm good. All right, let's focus, please, boys. So, step number 1, move C. So that means I need to take my C, my last term, my term without my x, and I need to move it to the other side of my equal sign. So right now it's a positive C, so I'm going to subtract it. So minus 16, minus 16. Cancel that on my left side, so I just have 12x squared minus 14x equals negative 16. Step number 1. Step number 2, we are told to add b over 2 squared. So that means I need to add negative 14 over 2 squared. But I need to add it to both sides, because once again, if I add something to one side, my balance is no longer balanced. It's unequal. So I need to add it to both sides. So So I'm adding negative 14 over 2 squared to both sides of my equation. Now, what is negative 14 divided by 2? 7? Negative 7, right. What's negative 7 squared? 49, positive 49, because it's a negative times a negative. So this can really be simplified to plus 49. So it's negative 16 plus 49. I just simplified that opposite of b over 2 for b over 2 squared. Then we get to go to step number 3, factor the left side. Yesterday we looked at that pattern, just like on that review. We know if it's a perfect square trinomial, we know we can always jump directly to what that factor is. It's always going to be our x plus b over 2 squared. That's always what our factor should end up like. So in this case, if b was negative 14, our b over 2 will be negative 7. So I can jump right to x minus 7 squared. One thing to pay attention to that I think I see the most students struggle with complete the square. Or not really that they struggle with, but just something that trips them up, is they forget about that sign in front of your b. So in this case, it's a negative 14. So negative 14 divided by 2 will give you a negative 7. A lot of times they'll just want to write positive 7, or they'll just write what that number is divided by 2 and forget the sign. So always watch out for that sign in there. That's one of the biggest mistakes I would see, especially last year. So we have x minus 7 squared is our factor. That was step number 3. Step number 4, we just need to simplify that right side. So I need to take negative 16 plus 49, and that gives me 33. So we went through those first 4 steps. We factored that left side, simplified my right side. Are we doing okay so far? Okay. Now, step number 5 is square root. In order to get rid of that square, I have to take the square root of both sides. Square root and squares are inverse operations. So I'm going to take the square root, cancel that out, take the square root. If my square root and my square cancel out, all I'm left with is just the inside, which is x minus 7. Here's where it gets slightly annoying though. Do I have a square root of 33? At least not a perfect one. So that's where we're going to have to use that calculator. So on your calculator, we're going to have to find the square root of 33. It's going to give you an ugly irrational number. So typically we like to round to 2 decimal places at the most, or at the least. So I have 5.74. You can round 2 decimal places, 3 decimal places. I typically go to 2. Is it just 5.74 though? Or is there another possibility? What's the square root of 1? Is that the only? 2 could also be negative 1. Because anytime we take the square root, we always have positive or negative as our solution. So we have to remember, with these quadratics, almost always they're hitting 2 solutions. They're having 2 x-intercepts. Once again, we're solving for those x-intercepts. So if we have 2 x-intercepts, we have to split up into 2 problems. So that means it's not just positive 5.74, it's also negative 5.74. Because negative 5.74 times negative 5.74 still gives you 33. And so our last step that we have is we just have to split up into 2 problems because we have a positive and a negative. So we have x minus 7 equals positive 5.74, and then x minus 7 equals negative 5.74. And the last step, I just have to solve for x, so I'll add 7, and that gives me x equals 12.74. And then I add 7, and x equals 1.26. And those are my 2 solutions for my quadratic. Once again, we're not always going to get nice numbers. We're not always going to get perfect answers to our quadratic. Sometimes you're going to get some ugly solutions. Sometimes we get some ugly solutions. But we have those calculators there. We have them for a reason, to help us take those square roots, to help us deal with those uglier numbers, to help us work with sometimes when we don't want to have to multiply, add, subtract, and deal with those ugly numbers. So, but if you were confused, just to make sure you got it correct, you could use quadratic formula, you could graph, you could factor, or we can take this number and plug it back into the equation. If you plug it back into the equation and get equals 0, then you know you did it right. Or as long as it's somewhere very, very close to 0 because we wrapped it a little bit. So once again, these were our 6 steps we used. First step, we had to move C. Then we had to add b over 2 squared to both sides. Then we factored my left side. I then simplified my right side. Took the square root of both of them, and then we split up into 2 problems to solve. Questions? What do you feel like is the most confusing step of the 6 so far? If you had to choose one.
Squaring.
The square root? Is it remembering the 2 solutions at the end, or just remembering to take the square root, or what part about it necessarily?
Remembering, I guess.
Remembering the square root. Well, for these first couple, we're going to keep this up on the board with us to help us remember what are our steps, how do we go through it, and so hopefully you should be able to look back at that and to remember the square root of this problem. All right, we're going to do one more together as a class, and then I'm going to give you one as sort of an example for you to try through. Sound okay? All right, so we're going to work through this one together once again, just to see another example, and then I'm going to give you the next one to try on your own. So once again, step number 1, I need to move C. So what should we do?
Minus 30 add 30 to 30.
Add 30. I always want to use that inverse operation. So my inverse of my negative is a positive, so I add 30. So x squared minus 4x equals 0 plus 30 is 30. So step number 1, I move C. Step number 2, I need to add b over 2 squared to both sides. So what should I add to my sides then? So x squared minus 4x plus negative 4 over 2 squared. Our b is negative 4. So it will be 30 plus negative 4 over 2 squared. So that was step number 2, add b over 2 squared to both sides. Step number 3, I need to factor. I can simplify this first if I want to and figure out what this number is, but I don't have to because I know there's a shortcut and I know what this factor is always going to give me. Because it's always going to be that x plus b over 2 squared. And so if my b is negative 4 over 2 is negative 2. So x minus 2 squared will be my factor. That was step number 3. Now I just need to simplify that right term. I need to simplify this negative 4 over 2 squared, figure out what that number is first before I can add it with 30. So negative 4 divided by 2 gives me negative 2 squared is 4, so 30 plus 4 is just 34. If you want to, you could honestly type this whole thing in the calculator as well. 30 plus parentheses negative 4 divided by 2 parentheses squared, and then we give you that same answer. If you're really lazy and you want to do it that way, go for it. Now this is where you guys said it was the hardest step. Step number 5, square root. So taking the square root of both sides, my square root cancels out my square, so I'm just left with what's on the inside, that x minus 2. And then I have to use my calculator for the other half. So square root of 34, we don't have a perfect square root of 34. It's going to be somewhere close to 6, but we don't know what it is. And so you have to use your calculator for that one. Gives us 5.83, I think. But I always need to remember, if I take the square root, not only do I have a positive solution, but there's also a possibility for a negative solution. So plus or minus. Last step, 2 problems. So I just need to split into 2 problems. X minus 2 equals 5.83. Then x minus 2 equals negative 5. And I just solve both of these, and I'm done. Plus 2, x gives me 7.83, and then plus 2, then x gives me negative 3.83. Once again, sometimes we're going to get ugly numbers, and that's okay. But we should almost always, unless for whatever reason you have 0, and you're taking the square root of 0, you should almost always get 2 solutions. Questions on any of the steps we took? I'll work with you in a moment. All right. Yes. Yes. Okay, that's fine. We'll just take it another time. Do you want to take it early on Thursday? We can do that if you want. Yeah. All right. I want you to try to attempt this one on your own. You have the steps. Review back to them. Use your calculator if you need it. Walk through those steps. Work with a partner if you need to. Give it a shot. All right, let's talk about this. All right, you should be throwing things. All right, I don't care.
What at me first. They're shocking me to things.
All right. Walk me through the steps. What was step number 1? Move C. So what did you do?
Add 21 and add 25.
Okay. What next?
What?
Yeah, being over.
Yeah.
What did that give you? What was our B that we added?
4 over 2 squared.
I like throwing paper at things.
All right. No one should be throwing paper. I don't care.
It's government.
We need to stop. All right. So I added B over 2 squared to both sides. Where do I go from here? Okay, what was that factor into? So, remember, that factoring the left side, we can do it normally and think what 2 numbers multiply to get this, what 2 numbers add to get this. But once again, it's always going to be that shortcut. It's always going to be x plus b over 2 squared every time. So if you know what that b is, you can jump right to that step of being, oh, if b is 4, then 4 divided by 2 is 2, so it's x plus 2 squared. So it's always going to be that shortcut. So keep that in the back of your mind. The next step, I have to simplify the right side. So what does this whole thing simplify down to? So 4 divided by 2 is 2, then squared gives me 4, and then plus 21 gives me 25. Next step. I square root my left side, square root my right side? If I move to one side, I have to do both. If I square root my left side, all of that cancels out except for what's left inside. So it's just that x plus 2. Just 5 though? Positive or negative 5. We're always going to get those two answers. Because remember, negative 5 times negative 5 also equals 25. So they both are solutions.
So,
Last step. So I saw one where it's positive 5 and one where it's minus 5. So x plus 2 equals 5. I can just subtract 2. It gives me x equals 3 as one solution. I subtract 2, and x equals negative 7 as my other solution. So 3 and negative 7 are two solutions for the problem. Once again, if you want to check your answer, just to make sure, take that quadratic that you started with, that original quadratic, and plug in 3 for your x. Plug in 7 for your x. If it gives you 0 as your answer, then you should have it right. If you rounded decimals, if you had some ugly numbers and had to round a little bit, as long as you get very close to 0, you should be good. All right, so I know we're cutting it close on time. I want to show you one quick little thing that we're going to talk about tomorrow. What is different about this quadratic than the other ones? What do you mean?
There's an X, there's a 4.
People,
We have a leading coefficient for this quadratic. It has an A. So if your quadratic has an A, complete the square does not work normally. We have to do one extra step. And it's at the very beginning. So if your quadratic has an A, the very first step that you need to do, instead of moving C, is we have to divide by A. So that means I have to divide everything by 4. So some of these are going to turn into ugly numbers. So sometimes we might get some ugly, grosser numbers. That's okay. We have those calculators, we can deal with it. But I have to divide everything by it. I have to make sure it's everything. If I skip something, it's going to mess me up. So 4 divided by 4 leaves me with just an x squared. Or 1x squared, same idea. Negative 22 divided by 4 gives me a negative 5.5. 10 divided by 4, 2.5. 0 divided by 4 is 0. So as soon as we divide by A, our quadratic no longer has that leading coefficient. Technically I have 1 there, but I could write that 1 and I could not write the 1. It'd still be the same thing, whether I have this here or not. Colton, do you need attention?
Yeah.
Alright, what have I said about throwing paper in the box? What did you just do? Alright, one more, and we're done. Understood? So, if there is a leading coefficient, your step number 1 is now divide by A. Once you change that, once you get rid of that A, once you change all those numbers, it's just a normal complete the square. You might have some uglier numbers to deal with, like our B divided by 2 is going to be a little bit uglier, and we'll have to square it, and we're going to get some ugly numbers, but we have those calculators for a reason. But this is still just a normal complete the square as soon as you get rid of that A. So really, if you think about it, there is one extra step. Instead of moving C being your first step, it should really be divide by A as your first step. But other than that, that's the only thing that it changes. Are we okay with this? Alright, we're going to see this more tomorrow. Practice with working when we have an A, some of those ugly numbers.
you name your